All right. And now in this video, guys, we are going to do question 9. The previous video that I released, it was question 8. This is going to be question 9. So we know that we are completed or we are done with calculus. I'm not sure if there's another question after this. I didn't really check. Right. So this question here, they're not asking us to find out what are the x-intercepts, which is quite surprising, considering the fact that most of the times they ask us to calculate that value, but in this case, they didn't. So let's see what they have in store for us. Now, the equation that we are given is f of x is equal to x cubed minus 8x squared plus 5x plus 14. This is what we are given, and they want us to find out what is the coordinates of E, sorry. And what we all know is that E is a turning point. I'm sure they say that it's a turning point, also known as the stationary point when it comes to this. So if it's a stationary point, we need to find the first derivative and equate it to 0. So f prime x is equal to 3x squared minus 16x plus 5. Now we need to equate that to 0 and solve. Therefore, I'm going to write 3x squared minus 16x plus 5 is going to be equal to 0. Okay, I'm going to take a chance and try to just factorize this without using, I don't like the quadratic equation. If you watch the first video on question 1, you would know, right? So we're going to say 3x, and then we're going to say x is equal to 0. Right, 5 is just coming like 5. So I'm going to put 5 over there, and I'm going to put 1 over there. Right, if I say minus and minus, now let's see what happens. This and that will give us minus 15, right? Minus 15x. This and this will give us minus x. So this gives us minus 16x. So right on, spot on, spot on. Okay, therefore, x is going to be equal to 1 over 3, or x is going to be equal to 5, as you can see there. Now we need to find out what is the value of E. So the first turning point over here on our D is going to be 1 over 3. That will be x. We're not sure of the y value. In case when they ask us to find that, then we might. Okay. Okay. And what else? We know that this point now is going to be 5. Right? The x value is going to be 5. What did they say? They want the entire odd coordinate. So we need to substitute the 5. So we'll say 5. And then we're going to put, sorry, not 5, f of x prime. We are going to say f of x. We're going to say f, but we're going to put 5 there because in every place of x, we're going to put 5. So say 5 cubed minus 8, right, 5 squared plus 5 and 5, right, plus 14. Now, real quickly, let's just find out what that is going to be equal to. Okay, 5 cubed minus 8, minus 8, 5 squared plus 5, right, 5 plus 14. Okay, my answer that I'm getting is minus 36. So that means that when x is 5, y is minus 36. So that is how we're going to get that minus 36 over there. Easy. I guess you could have gotten yourself an easy 4 marks there. Right? Think about it. Think about it. This is not a question out of the blue. It's a question that you should be familiar with. Okay. The following question, they're asking for us to write down the value for which this graph here is concave upwards. Right, so let me just rewrite this. F of x is equal to, okay, sorry about that. F of x is equal to x cubed minus 8x squared plus 5x plus 14. The derivative, first derivative, is going to be equal to 3x squared minus 16x plus 5. We need to equate the second derivative to 0. Now, concave upwards is when the derivative of the derivative is greater than 0. But if the derivative of the derivative is less than 0, then it's going to be, or it's going to be concave down, right? Concave up is when the derivative of the derivative is greater than 0. Concave down is when the derivative of the derivative is less than 0. Right, now let's derive the derivative. Right, is equal to 6x minus 16. We need to equate this to 0, right? Minus 16 is equal to 0. Therefore, 6x is equal to 16. Right, now let's divide by 6. Divide by 6. X is going to be equal to, what do we get? I think we can just leave it as it is. or we can divide both by 2, so it will be 8 over 3, right? You can see that x, the answer that we are getting is greater than 0, right? As you can see, x, okay, hold on. Okay, guys, right, watch. For when the derivative of the derivative, right, when the derivative of the derivative is less than 0, that means our graph is concave up. When the derivative of the derivative is greater than 0, that means when the derivative of the derivative is greater than 0, that means our graph is concave down. Does that make sense? If it's greater than 0, that means our graph is concave down. If it is less than 0, that means our graph is concave up. It's going to look like this. But they are asking for concave down. So as you can see, our answer is less than 0. Or rather, what you can just do is, where is the step here? Okay, on this step here, where you have the derivative, for concave down, the derivative of the derivative has to be less than 0, right? For it to be concave down, the derivative of the derivative has to be less than 0. So let me just use a different color. This is what you will do. I hope I'm making sense, right? Derivative of the derivative has to be less than 0. This is for concave downwards, right? For concave down, derivative of the derivative is less than 0. So now what you can easily just do is write 6x minus 16, and then you say less than 0, and you can just solve and say 6x is equal to 16 and divide both sides by 6. Divide by 6, x is going to be, as you can see, x is going to be less than 8 over 3. Okay, you can leave the answer like that. That is correct. This one here would get you a bit confusing because you need to find out where it is where is this point, where does the graph starts getting concave up. Okay, so this would make more sense, right? You can just leave the answer like this. So concave down is when the derivative of the derivative is less than 0. Concave up is when the derivative of the derivative is greater than greater than 0. All right, so allow me to just erase this and move on. Let's do the following question now. Okay, the following question. Okay, we've got this. What was that? X is less than 8 over. Hold on. Let me just write the answer for this one here. X was less than, was it 8 over 3? 8 over 3. Okay, the following question. Oh, look at this. We need to find out the coordinates of B. Okay, uh, the coordinates of B, right, where, okay, actually they said x is 2. So x is 2 and y is 0. Okay. Okay, why am I multiplying? Okay, 0 there. X is 2, y is 0. Now, use the graph to determine the values of x for which f of x times the derivative of the derivative is less than 0. Okay, that's an interesting question that they have here. Okay, we need to use this equation to find out where the derivative of the derivative is when you take the first derivative and when you multiply with the second derivative is going to be equal to 0. Okay, so basically, looking at this equation here, right, we know that, guys, use the graph. They said use the graph. So let's try to just look at it and try to use the graph. Okay, what we're going to understand is that, do we need another point? Do we need another point? Okay. Okay, so let's see. They want us to get the coordinates where the graph, right, when we have the graph and the derivative of the derivative are less than 0. So that means that we are going to look for the points when one has to be increasing, or the graph itself has to be increasing, and the derivative of the derivative has to be decreasing. Okay, now what do we need to do? We need to understand what is the derivative first. The derivative gives us the gradient at any point. Now the derivative of the derivative Okay, the derivative of this one here is a parabola, right? And the derivative of a parabola is going to be a straight line. So we need to know when a straight line is decreasing and our graph is increasing. Okay, that is what we're going to find out. Or what we can do is, okay, this one is very interesting. It's very interesting. Okay, okay, we can first, let's find out the x-intercepts. Okay, let's just calculate our x-intercepts and we can see where to go from there. Let's do that. Let's find out our x-intercepts. That won't be very hard. We have f of x is equal to x to the power of 3 minus 8x. So you see that if the graph was all downhill from question 1, um, it starts getting, a bit tricky in question 5. I mean, question in calculus, plus 14. Okay, let's have that like that. And then we need the x-intercept. So x-intercept, let y equal to 0, right? We use, or what I use is, I think they call it synthetic division. We're just going to find out what value we need to put in the place of x for the expression to be 0. So I'm going to start with 2. I'm going to say 2 cubed minus, okay, 2 cubed minus 8. Okay, minus 8 times 2. And I'm going to square that. I'm going to say plus 5. And then I'm going to put 2 there plus 14. My answer is 0, spot on. I took 2 and the answer was spot on. So 2 will be in our first brackets. Okay, so this is how I do it and how I show other guys to do it as well. Right, we're going to put 2 outside. Why? Because when you put 2 in the place of x, our answer would be 0. Okay, now we're going to take 1, take minus 8, take 5, and 14. What we're going to do here is very easy, right? What we now need to do is just take 1 and put it over there. Now what we'll do, we'll say 2 times 1 is 2. And then 2 plus minus 8 is minus 6. And then 2 times minus 6 will give us 12. Minus 12, right? Minus 12. If we add these two, minus 12 plus 5, we are going to get minus 7. Minus 7. And if we say minus 7 times 2, we are going to get minus 14. And if we add these two, we get 0. Now, we open our brackets, small one and a big one, right? In the small brackets, what should I say? In the small bracket, x is going to be equal to minus 2. Why? Because when you take out x, it has to be equal to 2, like that there. Okay, now what else do we do? We're going to say x squared over here, right? And then this, we're going to say x squared. Actually, yes, we are going to say x squared, and then here we're going to have, we are going to take our numbers, these numbers here. We're going to take these numbers here. We'll have minus 7 here, and we'll have minus 6 over here, but it will be minus 6. X is going to be like that, because when we multiply the last two, we need to get positive 14, as you can see there. So we have factorized it, guys. So that means that x is going to be equal to 2. And then over here, let's just open this x, right? What we have, we're going to have minus 7 and plus 1. Therefore, x is going to be equal to minus 1, or x is going to be equal to 7. That means that C has 7 on it and A has minus 1 on it. Now let's go and look at this question. We now have all the x values. Okay, we now have all our x values. Okay, so what are they really trying to ask for us to do here? Okay, what is it really that they want from us? What is it really? Okay, they say that the graph has to be positive. In other words, has to be above the y-axis. We need to find a point where our graph f of x is above the y-axis. Let's focus with when f of x, because positive, okay, wait guys, let me just erase this since we're already done with this. We are already done with this. Since we are already done with this, we already found our values, ne? So let's analyze this. Okay, we have f of x, right, times the derivative of it. Okay, watch this. This is very interesting. Is less than 0. So less than 0 means that one has to be a positive. Is either the graph has to be positive or its derivative has to be negative. The derivative of the derivative has to be negative. By negative and positive, guys, I mean that one graph has to be above the y-axis, the x-axis, and one has to be below. Does that make sense? One value the has to be above and the other has to be below. So when we look at between A and B, right, we can see that our graph is above the y-axis or the x-axis, sorry. It's above the x-axis. Now, what do we make of the derivative of the derivative? What does that derivative of the derivative really mean? Okay, what does that derivative of the derivative really mean? Because we need to understand that so that we can proceed with answering this question here. Okay, all right, guys. The derivative of the derivative, like in the previous question, just tells you concave up or concave down. So when your graph is concave down, the derivative of the derivative is what? The derivative of the derivative is less than 0. Okay, does that make sense? Does that make sense? Right, the derivative of the derivative has to be less than 0 for your graph. Okay, hold on. Concave. Oh, sorry, I'm making a mistake. The derivative of the derivative has to be, um, okay, wait, watch this. Between over here, our graph, right? Our graph is above, right? Our graph is above the y-axis. And then the shape of the graph, the shape is concave down, as you can see from here. From here, over here, the graph is concave down, but our graph is above. Okay, so just forget about what I was saying back there. Concave down is concave down, right? And it's above the x-axis. It's concave down and it's above the x-axis. That is going to be one of the answers that we're going to use. Okay, I know it's a bit confusing. But when you look at the graph over here, it's concave down, right? It's concave down, which means that it's a decreasing function, right? It's a decreasing function. And then the graph itself, as you can see between here and here, is above the y-axis. So guys, our answer will be -1, and x is between -1 and 2, right? But then we're going to write it like that. Okay, but then we don't stop over there. Guys. We also have this part here to think about. Now watch this. When you're between B and C, the entire graph is below, as we can all see that. The entire graph is below, meaning that f of x, right? F of x times f prime, f like that, right? Remember, it has to be -0. But when you're in this interval here, what you will notice is that the graph itself is negative because it's below. But now, when you look at this here, the shape, the cone. When you look at the cone, what is happening to its cone? It's concave up, but what's happening? What is happening? It's concave up. It's concave up. So it's, if it's concave up, then it has to be negative. Sorry. Okay. If it's concave up, then it's also less than 0, right? So both of them cannot give us what we want. Remember, concave up, the derivative of the derivative is going to be, okay, so you just need to know those basics, and we can't take this for our answer because the graph is both below. We have the graph is below, and then we can also see that our shape is below. So what we need to do now is to focus on this part over here, right? Where what you'll notice is the graph is above, but then it's also concave up, right? You see that it's above and it's concave up. Okay, I think it's a bit confusing, isn't it? It's a bit confusing. So we're going to take the value of our concave up, right? So we're going to say x, right? Our x is going to be between 7, okay, because 7 is this point here, 7 and Remember when we said concave down? All right, where we said our graph is concave down, it was okay when x was 8 over 3, right? 8 over 3. So we're going to say 8 over 3 over there, and then we're going to say x is greater than that, but x is less than that. Okay, x is going to be less than that. Right, guys, this one was a very confusing question. Okay, it was a very confusing question. Now let's do the following question and see what happens. Right, the following question that we've got here. Okay, even it takes, these are the questions that you hardly see in your question papers. They are just there so that you don't get yourself a distinction. That's how I view them. You know, they're just there so that you don't get your distinction. Because if they don't put those questions, everyone will be getting A's. Isn't that so? All right. So let's do the last part, the 6 marks, and see if we can get them. They say that for which values of t will y, okay, so we have the first equation. We have y is equal to minus 11x plus t, right? Uh, have intersect with the original graph. Okay, we can even just stop there. Let's just stop there and find out where these two graphs are meeting first. So the other graph is f of x is equal to x cubed minus 8x squared plus 5x plus 14. Right, what we need to do is equate them, find the derivative of this first. Guys, okay, watch this. This question could be done in two ways, right? But what do we know about these graphs here? We know that they are intersecting. So if they are going to intersect, we know something about the derivative. We know that at that point, they will share the same derivative, right? Because we have a straight line, which is definitely going to be passing through uh, through this point here, through this graph. So we need to find the first derivative of this, or you could have equated the two equations, right? But what I'm going to do is I'm going to find the first derivative because I know they share the same gradient at the point that they intersect. Okay, 3x squared minus 16x plus 5. Okay, that's what we have there. Now what we need to do is equate this to the gradient of this equation here. Okay, we're going to equate this to 11x. So x squared minus 16x plus 5 is equal to minus 11x. So sorry, not minus 11x, minus 11. Now let us solve. X, 3x squared minus 16x, right? So minus 5 plus 11, basically that's going to be 16, is equal to 0. So we have 16 and 16x. Okay, now let us just factorize that real quickly and find out what are our values of x. Okay, this is quite interesting. 3x, okay, and then we're going to say x is equal to 0. Okay, so we have 4 times 4. If we put 4 here and if we put 4 here, what we will have is going to be, that is going to give us 12. And then this will give us, so that 12x, and this will give us plus 4x. That is actually equal to 16. Wow, that is actually going to be equal to 16. But remember our signs, remember the signs now. This has to be negative, that will be negative. All right, straight away, straight away. Okay, now x is going to be equal to 4 over 3, or x is going to be equal to 4. But we don't stop there. Now let's find out what are the y values. Now, guys, remember, the two graphs are meeting at a certain point, right? When these two graphs are meeting, what is happening is that they are going to share the same x value, right? They're going to share the same x value, but also they share the same y value on that point. So far, we've used the gradient of the other question to find out where these point, to find the x values where these points are meeting. So now let's find out the y values. So we're just going to say f, okay, when x is 4 over 3, right, is equal to 4 over 3 cubed minus 8, 4 over 3 squared plus 5, right, and we're going to put 4 over 3 there plus 14. Real quickly in the calculator, if we say 4 over 3, close that to the power of 3 minus 8, and then we're going to put 4 over 3, close that, squared, plus 5, close that, 4 over 3, close that, plus 14. The answer that I'm getting is 238 over 27. So when x says 4 over 3, the answer is going to be that. Now let's try to find out when x is 4. Right, now let's try to find out when x is 4. So instead of deleting everything, I'm just going to say 4 over 1 wherever I have 4 over 3. Right, 4 over 1. Okay, I'm not going to write everything there now, guys. I'm going to say 4 over 1. And my number that I'm getting, y is going to be minus 30. Okay, so those are the 2 points when these graphs are meeting. Okay, that is the point. So x is going to be, okay, let me write that properly somewhere down here. Right, when x is 4 over 3, my y is going to be 238 over 27. Okay, and when x is 4, I'm going to have minus 30, like this. Okay, but that doesn't stop there. Remember, these two graphs are sharing something common. Now, guys, remember now these points here, we can take them into our equation, into our straight line, right? It was a very interesting question. We're going to take this equation, these coordinates into our straight line so we can solve for t, right? Let me just repeat one more time. When these two graphs are meeting, okay, when these two graphs are intersecting, what is happening? They share the same x values and the same y values, whatever point it is that they are meeting on. I think that is clear. But at this same point, they share the same gradient. Okay. At this same point, they are going to have a common gradient. Okay, not to say common gradient, but we have to equate the gradient of the straight line to the gradient of the derivative. Okay, to the derivative of the original function, not the gradient of the derivative. So the equation of a straight line was y is equal to minus 11x plus t. So let's put on our first coordinate. Okay, I'm going to try to put 30 first. Let me put 4. Y is 30 is equal to minus 11. X is going to be 4, right, plus t. Let's find out what is the value of t, where it has distinct roots. Okay, so what are we going to get? We're going to get minus 30 plus 44 is equal to t. Therefore, 14 would be our answer here. 14, right, is equal to t. Okay, but guys, what is t? T is when you look at the straight line, t is the y-intercept. Y-intercept, you let x be 0. So that means that some other value of t here is going to be 14. Okay, it's going to be 14. And then let's find out the other value when we substitute the other coordinate. So we're going to put 238 over 27 is equal to minus 11, and then we're going to put 4 over 3 here, right, plus t. Now let's just find out what we're going to get. We're going to get 238 over 27 plus 44 over 3 is equal to t. So real quickly, let me just put that on the calculator. 238, divide that by 27. Okay, sorry about that. Plus 44, divide by 3. Right, I'm getting a very awkward number, but it's fine. 634, divide that by 27. Our answer is going to be this. Now let's find out which one is bigger. Just convert that, you're going to get 23, right? Sorry about that, 23.48, right? So you can see that they want us to find out where okay, look, they say that for which values of t will this equation, the straight line, right, intersect f at 3 distinct routes. So 3 distinct routes means that if you draw a horizontal line, you get 3 x-intercepts. That's the first one, that's the second one, that's the third one. So let's just look at this one. right? We know that this graph extends. What are the values that we need in order to get three distinct roots? Like, what is the range? It will be over here, right? When y is minus 36, and then I'm not sure what value is going to be d, but let's just assume d was 7, right? So for us to get three distinct roots, our range would be y is in between 7 and minus 36, right? And then we just say that that is the range of us getting three distinct roots. But now we have a straight line involved, and we actually have two different t values that we have over here. And guys, that is going to be our range, right? For this question here, that is going to be our range. Okay, I would understand why you wouldn't get this question right if you explain it to me. Okay, because it's just a weird one. But there's a different way that you could have done it. Okay, so we're going to say t is in between which number is smaller, 14, which number is bigger, 23. So I'm going to say 634, divide that by 27, and we're just going to do that. That is going to be our range. Okay, but uh, is there a different way that you could have actually done it? Well, equating the two graphs together, right? If you equate the two graphs together and um, yeah, you could have just equated the two graphs together and found the derivative of whatever expression that you have, and then you solve for x, right? You solve for x and then you just substitute back into the equation, which would make more sense in a way, right? You would get the same answers though, right? What I mean is you take the original equation, you equate it to the equation of the straight line y, because at that point the two graphs are meeting. Okay, at that point the two graphs are meeting. Remember, t is just a constant term. Okay, guys, I'm going to be doing that question right now so that we all understand what I mean. If we had done it differently, because I don't think it's going to take a lot of time. So what we do, we equate both equations together, right? What is the first equation now? I don't see the first equation, but the answers are going to be the same anyways, right? So let's just say we're going to equate f of x to the equation of that line. So it will be x to the power of 3 minus 8x squared plus 5x plus 14 is going to be equal to minus 11, right? Minus 11x, sorry, minus 11x, what is it? Plus t. Now, what we will do, just transpose literally. We're going to have x squared, x cubed minus 8. Oh my goodness. Minus 8x squared plus 5x plus 11, right? Plus 11x. Okay, instead of plus 11x, I'm going to say plus 16x one time. Plus 16x, because I have 5x and I'm going to add 11. I'm going to say plus 14. Okay, you can even just bring the t to this side, minus t is equal to 0. Right now, you can just make this a different equation. Just make it maybe, what do we have? Do we have, just say g of x? Okay, let's just say this equation is equal to g of x. Now let's find its derivative. Now the derivative is going to be, watch this, is going to be 3x squared minus 16x, right, plus 16. Now we just have to factorize, because remember, the derivative has to be equal to 0 because it's a stationary point. Okay, so we have to assume that this line is a tangent. Okay, so we need to equate the derivative to 0. So 3x squared minus 16x plus 16 is equal to 0. You see, we are back to this, to the place where we were, and then we're going to say x is equal to 0. What did we use in the first place? I think we had 4 and 4, because this was going to give us 12. And then, right, guys, and then we need to substitute those points. Okay, so it's the same thing, different method, but it'll give you the same answer. Okay, so thank you guys for watching. It was a weird question, but you couldn't leave this question without at least 7 marks, let's say, or maybe, 9, 10 marks. You couldn't leave this question empty-handed. Okay, the next video is probably going to be on finance. So subscribe, like, comment, and share for more awesome content. I don't only post maths, I post building I post civil engineering subjects, like, tutorials on that. If you're interested in that after matric, this channel will be your gold mine. Until we meet again, cheers.